last thing, just thank you to Green Pages for hosting us again, and thank you to Liberty Mutual, apparently. That guy over there, especially for the food. Right. Ready? Ready to hand it off to you, Chris. Okay. Go ahead, welcome back.
Take it away, Christoph.
What?
I said take it away, Christoph.
Yeah, all right. Hello, user group. It's an honor for me to present tonight's talk on EventDriven Architecture. My name is Christoph Wienands. Just think there was a V, not a W. And I'd like to start with a little bit background how I got to this talk. So, I'm working for Siemens, not the furniture maker, but the German engineering company. And for the past 2 years, I've been moving from, say, 3-tier, N-tier systems to microservice and cloud-based systems. So I thought it's about time that I give a talk here and present some of the what I learned during that time. And so I thought, pretty straightforward, microservices, event-driven architectures. And when I then actually started researching all the material, trying to figure out what do I want to talk about, this is what came out of this. Brain freeze. So, like to give an example, event-driven architecture, there are about 4 or more interpretations of what event-driven can mean. And then there are all these related practices, patterns, liabilities that you incur if you make this or that choice. So it was the question where to start, where to end. So I hope that I found some kind of red thread through my presentation that I can follow, building on top, explaining certain concepts and build on top of each other. So here you see the outline. Now, quick question for you guys all over there. I need to step back, right? We need to see.
Okay.
Yeah. All right. Let's start with taking 2 quick looks at popular architectures. Then for patterns and liabilities discussions, that's going to get somewhat theoretical, and but I hope you're all fine with this. And in the end, I'm going to tie this into what I'm currently working on, and I even have a small demo for you. So that's good. Oh, by the way, if anybody has a question, just raise your hand, and I can call you at a good time. Keep it orderly. Okay. So I hope all of you know this standard 3-tier or N-tier architecture. Essentially, we're talking about the client. Nowadays, that's typically a browser in the front end that is retrieving data, processing the data, and then sending commands back to an application server. This application server, so in the context of N-tier architecture, is typically something more complex, where you have tightly integrated components that very quickly can chat with each other. But on the other hand, they're tightly coupled because they're all running within one server, or maybe I'll scale to 2 or 3 instances, but that already causes additional problems. Underneath that N-tier architecture, you will find typically one big database server, Microsoft SQL Server or Oracle, possibly MySQL. So the advantages of this is, so let me make this clear, there's nothing wrong with a 3-tier architecture. It's simple and straightforward. There are many developers who are familiar with it. It's easy to test. You usually have synchronous communication from the client all the way down to the database and back. So it's easy to trace. You get immediate consistency. Now, if you're wondering what is that, please hold that thought. That's a separate point I'll get to a bit. Just keep in mind this is actually pretty helpful and important. Could be very important. So the disadvantages to a 3-tier architecture is that as these systems grow, they become more and more difficult to maintain because you have the tight coupling. then they also get difficult to scale, particularly scale horizontally, meaning like run multiple of your application servers or run multiple instances of your database server can become very expensive as well. Now, let's contrast this with microservices. Microservices are, or how do we recognize that a system is built around using the microservices architecture? So some criteria are those services are built around business capabilities. So think a order processing service or a shipment service, a user login or authentication authorization service. So right from the get-go, you break your system into lots of smaller pieces around domain capabilities or business capabilities. Those services, they interact with each other using lightweight protocols. So think HTTP, lightweight message or event buses. Typically HTTP and REST APIs. So the opposite of dumb plumbing and lightweight would, for example, be Microsoft BizTalk, where you actually have workflow engines and data processing pipelines and all this in your communication layer. So as a result, your business logic now gets spread out over some business logic components, those microservices, and your communication layer. We don't have that typically in a microservices architecture. Another pretty interesting or beneficial concept is the data management or data storage, because unlike in an end-tier system where there's one big fat database in the back end that serves all the business logic, each microservice can have its own optimized data store, whether that's for some read-heavy service that could be DynamoDB or even a Redis in-memory cache, whereas other applications might just choose a relational database. So the choice is really up to whoever builds that microservice to make an optimal choice. Okay. And another practice that's not so much technical, but like the process, human processes related, is the automation of infrastructure. Some months ago, we had a talk on cloud formation, which helps us with a click of a button to bring up an entire environment or instance of our system with databases, services, containers, security groups, routing rules, and so on. Continuous integration and continuous development fall under these. Now, those practices aren't exclusive to microservices, but they are a lot easier to realize using microservices. If you think of a line of business application, so think monolith, that might require some big install shield setup package that takes start to finish 2 hours to install and configure. That doesn't lend itself to automation or bring environments up and down really quickly. So some more cons and pros and cons. These services are, because they interact with each other based on contracts, it's perfectly feasible to replace them, to upgrade them with newer versions that have new capabilities. Then other services might follow suit and use these new capabilities. So because you have this decoupling, it's a lot easier. It's possible to upgrade them step by step. They scale well, because for each microservice, I can choose to run 1, 5, or 10, or 20 instances, because if I design them properly, so that the interfaces and contracts are can handle processing in parallel. Then I mentioned this, for each microservice I can choose database technology, database storage that I want underneath, but I can also vary in the programming language or the technology stack that they're implemented with. In our case, actually, at Siemens, the team that I'm working with, they're pretty good with Node.js and okay with relational databases. So that's our go-to choice for microservices. Whereas other teams, they went to Go and DynamoDB. Now, I haven't seen really much success from them yet, but we'll see. I can report that in a few months. On the con side, it does require a more skilled team. So I mentioned that was a three-tier architecture. I expect everybody coming out of college knows that. It's easy to build. Whereas microservices, you have to think a lot more about the interaction patterns, design the contracts properly. Communication between them is more expensive. So the instances of services are typically spread across multiple machines or virtual machines. Any communication between them always goes over the network. Whereas within three-tier, inside the application server of the three-tier architecture, it's all either in process or at least within the machine. So pretty fast and low latency. Yes?
When you say expensive communication, are you talking about costing across like an AWS platform, or are you talking about the inherent the lag between the transfer of ones and zeros across a wire?
Yes, so thanks for that question. So I'm not talking in terms of money cost, but just the latency. If you want to ship or send 100 kilobytes or half a megabyte, some of those services might actually have upper limits, that they don't even take that amount of data. You have this problem a lot less with an in-process or with a traditional server application. And because these services, to some degree, still have to work together with each other, but services can be down for maintenance, currently be upgraded, or just not reachable because of overload. So you have to consider design for failure right from the start, really plan such an architecture. Okay. Before we get to patterns, and any questions about those two architecture types? Okay.
Actually, so if you go on the last slide, you design for failure. You still have to design for failure with a three-tier or n-tier architecture. What different type of failures are you designing for, and what was the mindset shift that you kind of have to be aware of?
So with a three-tier architecture, it's usually either your server is there or not. If the server goes down, you can do some a hot standby solution and fail over, let that continue. Depending on the technology, that's a matter of seconds or minutes. It has to boot. Whereas with microservices, you don't switch over. But I actually have a couple of measures, and we'll get to some measures how to increase reliability. So I would say let's hold that thought. Okay. So possibly the easiest pattern that I'm getting into today is it goes by this wonderful name, Command Query Responsibility Segregation. So it sounds overwhelming. If you read up on EventDriven Architecture, you'll usually find this abbreviated as CQRS. And let me start with an example before we go into the theory behind this. So I'm currently building hypothetically, building a first-person shooter application where the users can reload their weapons faster for credits. So they have to, because I'm in the market to make money, so they can buy credits and then reload their guns, their gun, without having to wait to find an ammo pack. Another capability in that system is that the user can switch the primary weapon from a gun to a shotgun or machine gun or something like this. So in a first version in version 1, this is the REST API that I came up with for these two operations. So obviously the UI needs to be able to get information about the currently selected primary weapon and maybe about others. So there's a get endpoint where I can specify which weapon I want to get information. So there's remaining ammo, max ammo, how much does the magazine hold, and whether it's currently the primary weapon. So pretty straightforward. Now for those two operations, I've chosen to use a put operation. So as a reminder, in the REST APIs you have those four, well, technically, actually it's usually 5, but 4 frequently used verbs: get, post, put, and delete. They correspond to get what is read in terms of databases. The put is update, the post is create, and delete is delete. So as technical people who have learned something about databases, it just comes somewhat natural for us to create these REST APIs in CRUD style. So what I've done here is, if I want to reload the weapon, the client sends back a weapons object where the ammo was set to 10. So that tells the server, okay, I'm just bumping up, take that ammo from my credits. And for the reload, there's a put request to another weapon, and it says, okay, now this one here, this is the primary weapon. So notice a few suboptimal attributes of this solution. One thing, not the worst thing, but these put operations actually change multiple entities. So when I reload a gun, it's also decreasing my credits. So 2 objects that got changed, even though I sent a request to a weapon. Well, the same thing here. If I switch primary weapon, one becomes not the primary, and the other one becomes primary. The next point is that within kind of the same object and operation, we're now implicitly encoding 2 completely different business operations. So here, it means if the server receives this and has to interpret this operation, it's, okay, this is going from 5 to 10, it means that the user wants to reload. Over here, the primary weapon flag has changed, it means the user wants to change this. If you talk to a domain expert, they have no idea about what you're talking about here, because this is totally CRUD and comes out of our technical mind. The word I like to use is we're shoehorning business operations into these bad CRUD style operations. So CQRS to the rescue. What we essentially do is introduce command objects. So let me just go back one here. So instead of sending back a weapons object with one or more properties of that object, we're now introducing true command objects. While at the same time, we're still using the HTTP verbs, post, put, delete, together with these commands. So if I have a command to create something, it would be a post. Something to change something, a kind of change command would be a put. The payload that I might be sending is command and the type, and then only the properties that are truly necessary for the command that I'm sending. So there's 0 ambiguity on the receiving side with what the user wants to do. So the operation becomes a lot more concise. And in these cases, actually, really, those commands don't even have properties. So it becomes very intuitive, both for people, for someone implementing the server side, as well as for say, a UI developer who needs to interact with this backend. So now that we've introduced the concept of commands, this is where the segregation comes in. because we, at least on a conceptual level, split all the get operations from those operations that change the system, that perform commands. And now if you take this thought further, it could be that even these query handlers for the read queries have their own specialized database that's different from the database that the command handler is using. How that is possible, we'll get to in a moment, the next pattern. But so that's essentially the idea behind CQRS. You split read from all the other operations and you introduce command objects as a better way than doing these CRUD style REST APIs. Let's see. Yep. So, any questions about this? Okay.
What's shoehorning operation? I'm sorry.
Say again?
Shoehorning operation. What does it mean? I'm not familiar with.
So, what I'm referring to with this is that so take this example to reload a web. The intent is clearly I, as a user, want to reload the web, but I'm communicating this intent by changing some data values. Okay, and that in my mind is shoehorning. You're trying to fit some concept into another one, and it doesn't really map nicely. Then there's room for interpretation. So,
Well, thank you.
okay. Next pattern, finally, event-driven architecture. And I mentioned those at least four flavors earlier. And so let's clarify which one I'm actually talking about. And it has another wonderful name, event carried state transfer. Unfortunately, I'm not aware of any good acronym, or didn't see any acronym for this online. So I'll just call it event-driven architecture for the purpose of this talk. And let's start again with an example, introduce some problems here. Given is that my company has a shopping cart service and a customer service. Customer service is not necessarily bad, always bad. Up to now, those two services don't really communicate with each other. But now the product manager introduced a new feature, discounts for customers who buy a lot. So 2, 3, 4, 5, 10%. And the information which customer gets a discount is stored. The master is the customer service. So developer number one comes along, sure, I'll add an API method to customer service and just have the cart service call that. And for each shopping cart that is being processed and where the service needs to calculate the order total and apply the discount, it makes a query to this customer service. What do you think what happened? The service here was like a really tiny low-key service that was never built for many requests, whereas this service here is meant to process 100,000 transactions per day. So just giving you an example here. So now with this service making 100,000 calls to this one, it starts completely overloading the service, unintended side effect. So this service now the latency increases, or maybe even the request timeout. So now all of a sudden the shopping cart processing over here slows down or even breaks down because it can't get the discount information. Did I forget anything? Yeah. So ultimately, with this little simple call here between services, we've dramatically reduced the scalability and availability and reliability of this microservice architecture. So how can we improve on that situation? And I think that will I think address part of what you asked before. How can we increase or design for failure and increase reliability? And the core of the solution is that we introduce an event program. in order to decouple those two services. So what this customer service now will do is publish change events. So for example, today this customer Christoph was at 2%. Now, because it's the new month, I got bumped up to 5%. So this customer service publishes event, customer changed, and in the situation or the scenario that I'm describing here, it just publishes the entire user object with all information. Could theoretically be optimized with just changed info, but anyway, so it publishes a changed event. Now, this shopping cart service subscribes to customer changed events, receives the event that I'm now at 5%, and it caches this information in its internal data store. So someone will have to place it on a table there, or possibly on the data store. And so essentially it mirrors the information from one service to the other. And now what happens is during those 100,000 order requests that are being processed every day, the information is right here. And I can scale up this as much as possible. And the only change I had to make here is publish the data, which from a performance point of view is peanuts. Probably doesn't even show up as a blip. So, okay.
Any question?
Yes, go ahead.
So how do you ensure consistency between the two?
We'll get to that too. That's the Atomicity last point here. So, but okay, to summarize, no, I don't need to summarize. There's a slide later. Example number 2 is the Facebook wall. So Facebook has what, a couple hundred million, if not billion, of users. Let's say, in average, every user checks their wall multiple times a day. Each user creates one or more posts, checks in or shares images whatsoever. But now the thing is, when you look at your wall, you don't see all the things that happen with your friends. Friends with 1,000 people, I don't get all the posts and updates that they share. So Facebook has this secret sauce algorithm that figures out which of my friends' posts I might be most interested in. And chances are that this is not a simple, quick algorithm, but it takes processing time to look at all this data and figure out what needs to be shown. So the question is, how can Facebook show this information really efficiently and fast when I go to my wall within seconds? And similar to the example with the customer service and the card service, here on the right side, we have all these change events coming in from various other microservices. Those get published onto the event broker, and then say that the wall, so this is hypothetical, it fits my talk here. But the wall service now processes all these events, runs its super wall algorithm, and then it could really, like, per user, store which posts are are right now visible to this user. So it pre-calculates all this. It's a denormalized data model. If you think in SQL, you would typically have a normalized data model, do joins and all that. Here, it's exactly the opposite. Possibly pre-calculate everything that can be pre-calculated, and then if I go to my wall, it's one GET request that sends the first 20 or 30 posts that are displayed as I scroll down, another read query with paging down into this table, and 0 calculations at that time. At this point in time, I'd like to introduce 2 other terms, the write model and the read model. So think back to the CQRS, where we had some operations that handle commands, which typically result in the state of my application changing. So my application or system has these domain objects, customers, orders, shipments, user logins, so those main entities. And any change to this, that really belongs to the right model. Then all these read queries and underlying data stores that serve these read queries, those are called the read model. So you'll find these two terms pretty frequently used as well when reading about the event-driven architecture. So let's quickly recap pros and cons. To answer your question again, by using this event broker and asynchronous publishing of events, I'm effectively increasing or decouple my system, increase the scalability, increase the reliability, because like in the customer service and card service example, customer service could be down for a day. Doesn't matter. The order service or card service has the information stored. It might get out of date a little bit, but chances are my business won't care if a customer ordered with an outdated discount for a day. Could still, if necessary, correct this afterwards manually. We're not introducing additional load on the supplier on the right model side of this, on the suppliers of that data. Because we're shifting all that work to the pre-calculating or the generating of these read models, we're shifting the load from read actually to the right side. There are some statistics that typically applications serve about 10 times as many read queries or read operations than write operations. So it just makes total sense to we'll move that work up front away from the read side. The disadvantages or liabilities that we're getting with this approach is we have data duplication. With Facebook, I mean, I'd imagine that could end up as quite a lot. But again, it's a business decision ultimately. Are we willing to spend the money on this duplicated data storage, these additional read models, in order to make our customers happier, or save money on the processing preparation side? The consumers, so the read model side, may have to process quite some complex state changes. Say if as part of an order processing, order changes, a shipment gets created, and maybe a ticket was generated, a read model may have to bring together all these events that come in at different times, like, not as one packet. And now we're almost there at eventual consistency. Just in a nutshell, to give an example, if I create a new post on Facebook, anybody looking at my public, the publicly visible wall, it will take up to 3 minutes for my post to show up. So that's in a nutshell, that a write operation, creating a new post, will only show up in these read models possibly minutes or even hours later.
Is there a way to set that? So is there a way to set how long that takes or how frequently that processes?
You can architect your system if, around so say it under normal operations has to be updated within 5 seconds. Then you'd have to architect your system around this. Use some kind of low latency event broker, and provide enough processing powers to get these change events pushed through into your read models. Again, business decision. But then there are also some measures or mitigation measures how you can, like if 5 seconds is just not feasible, cost effective to achieve that, there are some other measures you can take. I'll get to that. Actually,
what about circular dependencies in the first one? So your example of the cart calling the customer service to see what the discount is, but then the cart also has to update the customer based on their orders to potentially change their discount. Like, how do you handle circular dependencies in that?
so I wouldn't, just for everybody else, example was the shopping cart service calls the customer service, or at least relies on data from it. Then the customer service might require data from the shopping cart service. So we have some back and forth transfer of data. Let's not call it calls, but transfer of data in order to fulfill these long-running cross-service business workflows. It's actually not a circular dependency. It's just really a long-running workflow. And yes, we don't have this nice dependency graph like you're used to from NT architecture, but there's principally nothing. I don't think that there's anything wrong with this. Just to throw another term out there, there's the saga pattern, which actually allows you to kind of orchestrate these cross-service workflows in a little bit more transparent, controllable way. But that didn't fit in here. So just look for saga.
Okay, thank you.
Back to eventual consistency. The opposite, obviously, is immediate consistency. Think of the three-tier system. User clicks, okay, save this object. The object goes to the server application. That's a synchronous call. A transaction runs, writes the data into the database. Transaction commits, and the application server sends back the result. And if the client does an immediate read operation, it's exactly the data that was just written to the database. As we've already established, like with Facebook, this is not the case anymore. So we'll have to deal with this. And typically you get this liability or this side effect then in event-driven systems. And we take this liability because we can make our system more scalable and reliable. So how, before going into the measures, how we can work around this problem, just a general word of advice. This eventual consistency is okay in task type applications or operations. So think of I place an order. People are used to, okay, there's a spinning wheel or your order is in process. Please wait until we've pulled all the material or charge your credit card. So for such use cases, the user acceptance is pretty high. People get what the system is doing, that it's not instantaneous. On the other hand, if I build some kind of spreadsheet application where I can fill in cells, tab to the next, and hit the enter button within 0.5 seconds and expect the result to be calculated, there's no room for eventual consistency, like old values showing up in cells or the calculation not immediately going through. So, right, I can keep that in mind when you're looking at user interfaces and the services that back those, whether you can actually afford to or get enough user acceptance with eventual consistency. So, but how if we just, because we need the scalability, can't work around it, how can we mitigate that? There's the session local concept. It's pretty simple. A client makes a write or an update operation, or even delete to the server, and just keeps that submitted information in its own locally cached data. It modifies it, adds or removes this object until the server-side read model is updated, and it can replace that temporarily cached copy with the new object coming from the server. Then, like in the case of submitting an order for processing with the spinning wheel, that's essentially polling, or can be realized with polling. Just poll the read model until, hey, is my order there? Is my order there? Until it is. To optimize this a little bit, you can use SignalR or WebSockets, essentially some kind of a push notification mechanism, so that the client doesn't have to keep on polling, but precisely then when the read model is ready, gets a notification. What was that, a hand raise or just?
Later.
Yeah. Okay. One kind of a small measure, but what I wanted to point out is here, because objects may get created asynchronously in that backend microservice system, it's oftentimes advisable that IDs get generated either by the client, just put a new GUID, or by the command handler that can then return this directly to the client, so that the client has the capability to actually read this updated or new, particularly new data once the read models are updated. And this last point here is a little bit inconspicuous here, hidden at the very end, but it's actually probably another half talk, compensating transactions, because it may happen that, say, two users, I mean, if you think eBay, two users try to purchase or bid on that same item right before the item, before the bidding period ends. Now, the bidding logic accepts both, because it's you working on some outdated asynchronous data, and then at some point in time where these get processed, one of the two will win. Then there will have to compensation to say, okay, I'm sorry, even though I accepted your bid, you were actually late. You didn't get it. So, last ability. Yes?
I do have a comment. I mean, another thing that's what I kind of like this idea as an example of booking your airfare tickets. They obviously use microservices or a similar idea, and you can have multiple different databases for different services. And the services are, one is look up which seats are available on the flight, and the second service is select the seat. So the first one is eventually consistent, because it doesn't really matter if you're outdated. The second one, though, is actually hard tied to the one database. Everything else is a replica, but there's only one right database, and when you're booking it, you are actually writing to immediately consistent database, and only after you get okay, that's when you get an answer back. So you have this kind of mixed situation where you have eventual consistency for reviewing effectively and immediate one for writing. I kind of like the idea of how they solve it.
That's a great idea with seats in airfare booking process. The read model obviously is maybe out of date because someone else just reserved that seat, but still, the UI, the client does some essentially pre-validation. Yes, right now it still looks free. And then it would have some compensation would have to go on in the back end to fix this. Like put the guy on a different seat or not give a seat at all. Right. So who asked about these guarantees that these events get published onto the event bus? What was that, you?
That was me.
Okay, so let's get to atomicity of states and events. I'm working, the assumption here is that it's not feasible to have distributed transactions in the cloud. You can do that in a 3-tier or N-tier architecture that's running on a few servers, but not in a cloud environment. I haven't seen this yet, in any case. So what what may happen is, without any further mitigation measures, say the command handler first updates the write model, my application state. Within the event broker, there's a network problem. That call gets lost. So now my database has been updated, but all the read models can't become in sync anymore. And exactly the other way around, if this gets first published and then the database call fails because a unique constraint, a foreign key constraint was violated, again, the read models are out of sync. And there are, I'm aware of five concepts how you can essentially make the updates in your write model and the publishing of events atomic. They all essentially involve the database to some degree. So which ones you can choose depend on which underlying data store you have. Like here, this fourth one, which I'll actually demo in a little bit. This one uses DynamoDB streams, something that other databases don't have. Okay. Now, this application events measure here, I picked this out because this is actually what we're using in the project that I'm doing. Underlying database is MySQL, and MySQL supports transactions. We've introduced a new event table, and any business logic that causes state changes starts a local transaction, which is no problem even in the cloud when you're working with a MySQL or Aurora database. Does the domain object changes, right model changes. It inserts the event to be published into this events table and then commits the transaction. If the transaction fails, both changes roll back. If it succeeds, both changes appear. And all you need now is some kind of worker that keeps polling the events table, looks, okay, are there new committed events? And if yes, publish them to the event bus and remove them from the database. Now, you may rightly notice that even here in these calls, something can go wrong. So what we will not achieve with this is an exactly once delivery. It could happen that the same event gets written out to the event bus multiple times, but we do have a guarantee of at least once. And if you study the like NFR non-functional characteristics of AWS Kinesis, SNS, message queue, most of them actually have either at least once or at most once guarantee. Only, I think, SQS in a certain mode guarantees exactly once.
You could use Kinesis too.
Say again?
You could also use Kinesis for this, right?
Kinesis?
Yeah.
Same problem.
Yeah. But even Kinesis, you'll get this at least once or so. So you need to be able to handle multiple events. The same
They're
events
working
coming
on
in.
exactly once. You're supposed to roll that out as an option.
Kinesis is? They are with Kinesis?
Yes.
They have that is one of the modes, one of the SQS modes though, too.
Yeah, now they have SQS with Lambda, so you could actually have that.
Still,
That's the event listener.
I believe with SQS, with Lambda, you cannot get exactly once guarantee. Pretty sure about that. So anyway, the other ones are essentially variations of this, where either triggers, right, create the data in this events table, or transaction log tailing, the transaction log coming out of an Aurora gets analyzed, and this event publisher can figure out what kind of business operations were behind this event, publish based on that. This one here, event sourcing, I'm not gonna get into this because that's yet probably a whole talk. Anyway, just be aware that there are multiple ways how to accomplish Atomicity. That gets me, so we're through with the theoretical part. Are you still with me?
Yeah.
Okay. So I mentioned earlier over the past 2 years.
Yeah, so it sounds like the event broker is pretty fundamental in this whole experience. What sort of redundancy or best practices to make sure that that isn't your single point of failure can you speak to?
A little bit. So I'm not an event broker specialist. I have some references in the back of this slide set. I found this article. It was a hugely detailed blog post about how to essentially set up such an event broker with AWS services and how to work around like these read restrictions on Kinesis streams, like you can only have X amount of consumers that try to read from it. So that might be a good start. But you're right, the event broker is the key of the entire system, and it's actually, I think, pretty difficult to get that really right and reliable.
So would you say that's one of the biggest flaws of microservices? It sounds like you come down to that exact same problem you faced with N tier, where if anything, if the event broker went down, it all goes down. Or whereas when you were on the N tier architecture, if any one component went down, it all went down.
So if you think of AWS services like SQS, Kinesis, SNS, those are highly reliable services. So if you can build your broker on top of those, you're already in pretty good shape.
So never use your own, always use a
Say
managed
again?
service. So never use your own event broker, always use a managed service.
Yeah,
It's kind of the,
Yeah, I mean, there's also Kafka. I don't know enough about these various
And in
brokers.
if you also use DynamoDB, then you have got like almost like 5 lines of reliability.
Yeah. So and if you have a company that's good at providing a managed Kafka service, you can achieve quite some high lines as well. Okay, so over the past 2 years, I've gotten into this cloud-based development, and I'll just need to move a little bit, so I'll draw this one here. The system that we're currently building is a microservice architecture, and each of those microservices has a different responsibility. For example, the one that I'm working on is concerned with users and organizations. There are sub-organizations. Users have memberships in these these organizations. So it's just really concerned about providing all the necessary information to make authorization decisions, authentication and authorization. Then another service is for licensing, subscriptions of organizations. Another one, let's call it a site service. It has concepts like campus, buildings, floors, rooms. So it can model the physical world. And here's another one, device service, where we can connect to systems out in the field, whether those are fire panel systems or comfort systems, or HVAC, and so they get connected to the cloud using IoT technology. And these services here, they're meant as reusable infrastructure services, because all these teams, they're part of a program, and in that program we also have a number of products. For example, one fire-specific product, one comfort-specific product. Those are websites, and they're supposed to make use of these reusable services that are even hosted and managed by an infrastructure and DevOps team. all these services, they are not allowed to call each other directly. So here, exactly this, the state transfer, what was that? The flavor of event-driven architecture that I explained earlier. One thing that I realized in the meantime after putting together this talk is that we are not using CQRS, and it would have made our life quite a bit easier, because each one of those services has its own API that needs to be specified as a REST API, and numerous times we were shoehorning those operations, like accept an invitation or invite a user into put operations where values change, or into post operations. So if I had known or been more aware of this some months ago, it would have made our life quite a bit easier. Regarding technology, so this is usually Angular 6. Our service, I mentioned that earlier, is implemented in Node with.
So these are Lambda functions, or what are these?
Yes, I'll get to that in my demo. So this is Aurora, but whereas other services they use Go and DynamoDB. And I mean, this service is already up and running. Others are integrating with it. As I said, those other ones are still under the development, so I can't report yet how suitable, especially the choice of DynamoDB is. Personally, I'm not a fan of it. I think it's really awkward. There's a lot of trade-offs, your liabilities that you're getting with that choice.
Is it DynamoDB you don't like, or is it NoSQL database?
It's specifically DynamoDB.
What do you not like, or what do you hope it would wake up with?
Right. So DynamoDB is all about how you partition your data. Like you have to choose proper partition keys, how your data gets spread across multiple servers. Then when you provision throughput capacity, like read and write capacity, that capacity gets distributed across all nodes that make up a specific table. Now what can happen is that's called the hotkey problem, that well, you have 100,000 users, but only 10 of them are active, and by coincidence they're all stored, because they're new users, also are all stored on one server. Now all of a sudden, this one server runs out of capacity, fails requests, whereas all the other servers have plenty of capacity, wasted capacity. So you need to over-provision, and just generally, I find it very difficult to. I'm a relational database guy. I admit it. I find it very difficult to map these object models onto DynamoDB with its partitioning and range keys, and then you can still have some in partition or global indexes. But so I find it very cumbersome. Is that enough?
I totally agree with you.
Okay. Sorry if that.
Even Redshift is the same situation.
Say again?
In Amazon Redshift, it's the same situation. If you get your sort keys wrong, you're like dead meat.
Yeah.
Because
So,
your nodes, it's the same thing, right? You have nodes on Redshift, and if your partition is not perfectly aligned, then it becomes similar hotkeys. One node gets all the load.
Right. So one thing I read in a like experience report is that some company they tried DynamoDB and it really did not work. When they scaled up or put load onto the system, it miserably failed, even with over provisioning DynamoDB. Then they switched to Google
Firebase. Firebase, right?
No, not Firebase. Some other big data.
Big table?
Yeah, maybe Big Table. I forget the exact name, but to a Google product, and what they reported is that at a much lower cost they can fulfill all their performance requirements, because that, I guess, doesn't have these restrictions. Yeah, so any other questions about this here? Because you see, so I said we're not using CQRS. We're doing event-driven architecture right now. This is actually an immediately consistent service, which we've chosen explicitly. The other guys, they'll also inherit this eventual consistency liability. Again, we'll see how that goes. And we've implemented this application event mechanism for Atomicity, because that works really well with
So
Aurora.
this is like a service Siemens is offering, or this is a custom product you're making for some customer?
Well, so it's not specific for one customer. It's going to be a public offering from Siemens, for example, for value-added partners who want to get insight into the installed field systems of the customers that they are managing.
This is specifically for building products?
Say again?
Or this is specifically for building products or any
Yes,
product?
yeah. So I work for Building Technologies
Okay.
inside Siemens. Okay. It is time for a demo. I still have like 10, probably less than 15 minutes of your attention. Someone had asked before. I just need to sit down now. Wait, I actually have slides for this. So someone had asked about Lambda before. So yes, in our application we're using Lambda and Node running inside Lambda. But now in this demo, I wanted to show a couple of these concepts. So first of all, the serverless framework. Who in here has not heard of the serverless framework yet? Everybody. Okay. So maybe this is an old hat for you. Now, what you see here in this communication chain from the Lambda to the DynamoDB table to back to Lambda and then to an SNS topic. This is this DynamoDB stream that I mentioned is one of the options for Atomicity. So I'm demonstrating this. There's a general listener here that just dumps all the events into an event history. We'll get to that use in a little bit. And then in this kind of like upward communication chain, this is a read model that so the business domain is there are some posts and I can like posts, and so based on these likes I can derive the top like posts, or I can get some trends of how many people over time clicked on like. Yeah, so the right model on the left side is the liking a post, and on the right side there's the read model for pre-calculating the like posts. This is all right. Now, so if I show you guys some serverless code, is that okay for you?
Can you flip it into night mode?
Is there a hotkey?
That's on a Mac, I don't think it's Windows, right?
The command palette
Oh, you
usually
know
lets
what?
you search for it.
I think you got to change the theme.
Yeah, here, let's try this. Dark?
Yeah,
That's it.
Okay,
Thank you.
I'm trying to zoom in. Huh.
Yeah, that's
Okay,
much better.
is that readable?
Yes.
Okay. So, with the serverless framework, it essentially makes developing Lambda-based microservices really, really easy. If you were to deploy a Lambda function manually, you'd be, I think, writing CloudFormation scripts for 10 different types of resources and trying to deploy those. Serverless does all that work for you. And for the write model, I have this command here, like post, and you may remember that there was this Lambda function that received the DynamoDB stream. That's this like stored function. So really, all I'm doing here is specifying, okay, this is exposed to HTTP. I'll show a little mock-up, actually not mock-up, like a quick and dirty UI in a moment. And for the like handler, if I deployed this to AWS right now, I would have to specify the DynamoDB stream, but this is all local, so the binding is essentially done somewhere further down. But so two functions for the write model, and for the read model, there's the event handler that listens to. Okay, there's a new like that someone liked the post, and then again an HTTP handler. Okay, what is that? Yeah, a get method to get my top 5 most liked posts. What this looks like in the UI is this here. I don't know how to switch that to night mode, but here this event log is essentially for debugging purposes. It's just showing the event history. Here's my write model. I can like any post, and then here on the right side, I have my top 5 posts. So let's do some action here. Let's see. For example, this here in New York Times. That is this post. I'm liking this. So now you'll see over here. This will go to. Is that? Let me check if the infrastructure is still running. Is. That's a bummer.
Wow, Bhutan.
Say again?
We rarely hear about Bhutan in US. It's a small country on the right side. What tiny Bhutan can be.
So, that's a bummer. Let me try one thing. I'll just restart my local serverless environment. Let's see if that does the trick. In the meantime, the say for example this like post method, I've written this in the CQRS style, so it's expecting what is it, like post. Yeah, okay. And anyway, so the command has a command type property, and based on that, this handler can dispatch which business logic method any needs to be invoked, which happens to be like post. And then inside like post, all it does is dump this like object into the DynamoDB database. The client created the ID of this like. So again, one of those mitigation measures. And by wiring the DynamoDB stream to yet another Lambda function, this method gets called, and all it does is publishes the entire event into an SNS topic, from where it then gets distributed to all other subscribers. Let's take a quick look here if this fixed it. All right, so no. Sorry.
No, it just
It switched to 14.
Yeah, your
Oh, it
model
did.
says-
Hey, okay. See, that's eventual consistency. As now if I wanted to, I can inspect this event, and obviously if I do this a few times, I just click like 5 times. This post is going up in ranking till it hits the top. And to round this demo off, where is it? PowerPoint. Okay. One enhancement that I figured is just too much for this talk here, but that is replay history. So the business case here is I'm adding another microservice that is supposed to show the trend over time, say over the past few days. So it will obviously use a very different read model and data storage that the top 5 posts uses. And unless I want to wait for a month until enough trend data has been collected from the time that I deployed the service, I need to have the capability to replay the history. So what I can do is say to the to my event history there, okay, replay the past 2 months of post-liked events, and this new trend service will listen to those, populate its read model, and once the read model is populated, I can switch it to live, and so possibly within 1 day, I can display trend data to my customers, even though I've never built my system to collect trend data initially. So there's a lot of value in this recording these events in an event-driven architecture, because you'll be able to oftentimes fulfill business needs that were never foreseen before you actually built your first version of the system. You're through. So I hope I found some red thread through all these concepts for you. Maybe in a year from now I'll cover the other half that I didn't get to yet. But now open for questions.
So any plans for switching to CQRS in your work?
That kind of depends. Like on how these products sitting on top, those again are made up of reusable Angular components that are specifically tied to these microservices that we're building. So if anything, it would be a major breaking change, or we'd have to like run 2 REST API versions in parallel,
Right.
while everybody who is working on the UI switches over to a command style.
Sure.
The command style operations. So at this point in time, no.
Any books on patterns?
Say again?
Books on patterns, can you recommend any?
So just FYI, these references, I haven't completed them yet because my bookmark list disappeared thanks to security restrictions on my company laptop. I know where to get them, complete that, and then I'll share that with Chris. But this first link, Microservices I/O patterns. They have it's not a book, but they have probably several dozens of patterns that they explain and correlate with each other. Like again, the liabilities that you're getting, how can you mitigate them with some other patterns. So that would be my starting point. And another one is the CQRS.nu FAQ. That one is, I would say, is less broad than Microservices I/O, but it has like some really detailed information and good advice, and that last link here really filled quite a number of white spots on my brain map. So if anything, I can recommend those 2. And for whoever wanted to build a event broker, is that you?
I know it sounds like building my own is not the right approach.
There's another link which I think it's this one here, the creating node. I'm not 100% sure, but anyway, I'll complete this, add some titles to what each reference
Where are you
is good
based
for.
on? Where are you physically based on?
Portsmouth. So I work from home,
Oh, okay.
fortunately.
All right.
All right.
Okay.
Thank you very much.
Nice.
Thanks,
You're welcome.
Thank you, Christoph.
everyone.